In this video, we're going to be looking at IVT and MVT, and these are pretty awesome theorems that you're going to be super excited that you got to learn. So starting with IVT, intermediate value theorem. Intermediate just is talking about a value in between. So if f of x is a continuous function such that f of a is not equal to f of b, then there must exist a c with that c in between a and b, such that f of c is then in between f of a and f of b. So what does that look like? Here we go. Here's a, here's b, and c is somewhere in between. Here we go. It could be like this. There is f of a, here is f of b, and f of c is somewhere in between. Now, it doesn't have to be an increasing function. It could go back and forth. It could be a decreasing function. Here's f of a, here's f of b, and it's just stating that there must be some f of c somewhere in there. That's it. Pretty awesome. Next, we're going to look at the mean value theorem. The mean value theorem is just basically awesome. Okay, it's looking at how, if you remember, in the beginning of the year when we were drawing secant lines, let me color it in for you here, drawing the secant lines, and that helped us to find the average velocity and go from there. We then learned, coloring again, tangent lines. That was more of the instantaneous velocity, and we did all that by slope. And what you can see here is the green line and the blue line that I drew are parallel, and we know lines that are parallel have the same slope. So in order to use this awesomeness, you first have to say, okay, if your function is continuous on the closed interval, make sure you're aware that it has to be on the closed interval, and it's differentiable on the open interval, then there's an f prime of c, the derivative, that I can find by doing the slope of f of b minus f of a all over b minus a. Okay, new favorite thing to write down ever. So now we're going to look at a couple functions and decide what can I do. First, let's graph this piecewise function. We can see we've got a parabola, we've got a nice quadratic, would be a fancier word, that it would have a max at 1 and going down, but at 0 we have 0, so that means that's filled in and that comes up there like an open circle and goes back down. So if there's a hole, is this function going to be able to be used for anything? Well, no, it's not continuous, so it can't play either game. Okay, so we move on. The next one, beautiful function. You've got a nice absolute value graph there, correct? When you're thinking about your absolute value graph, hopefully you're quickly thinking that, all right, that has a cusp. So even though this function is continuous and we can use the IVT, this is not a differentiable function because of the cusp, right? Created by the absolute value. That is not going to be able to use MVT. Okay, now, we've got a great cubic here. We know our polynomial functions. Polynomial functions are continuous. Polynomial functions are differentiable. So this one I could use MVT and IVT. Do we have to find it? So I had to go back and read my directions. So yes, since it is a continuous and differentiable function, we're going to find the values. So first thing you will do is plug in f of 0 is going to give me 1, right? Plug in the 0, that would take care of that. F of 2, a little more math here. 2 cubed plus 1, so 1/4 times 8, so I have 2 plus 1 is 3. So then we can find that there exists a c value such that f prime of c, so we would do 3 minus 1 over 2 minus 0, or 2 over 2, which is 1. So now we're going to look at this, and we will talk more about this if this stresses you out. This is a typical AP question using IVT and MVT, and they really like these. So if you have been zoning me out, this is the moment to come back, okay? So we start. They tell you very nice here, you got functions f and g are differentiable. That's nice to know. They're also nice to know that g is strictly increasing. The fact that they are differentiable means you now know that it's also continuous, correct? You go on through, they've given you specific values, and they've given you this gorgeous composition -8 right there. So part A, explain why there must be a value for r between 1 and 3 such that h of r equals -5. So first, we need to find out what happens at 1 and 3. What we're going to need to do is find the two values. So I'm going to do f of g of 1 minus 8. Start with that one, h of 1. So g of 1 is 2. And then f of 2 is 9. So 9 minus 8 is 1. So I'll put over here h of... So h of 1 is 1. And now we'll do h of 3. So f of g of 3 minus 8. So g of 3 is 4. F of 4 is -1 minus 8 is going to give me -9. So h of 3 is -9. So what we're going to say here, we're going to start by saying, since the function, or you can say h of t, is continuous, and we would have a range is from -9 to 1. You could also use the square brackets as well. Since we have a range between -9 and 1, there must exist an r by IVT then that r between 1 and 3 So there must exist an r by IVT between 1 and 3 such that h of r can equal -5 because that is between -9 and 1. And then part B says, explain why there must be a value between 1 and 3 such that h prime of c is -5. Okay, so now we're going to use MVT. We're going to use the two values. Let me just pop back and get them. We have 1 and 9, a -9. So we would say, okay, h of 1 is 1, h of 3 is -9. Let's do slope of those two. So 1 minus -9 over 1 minus 3, so I end up with 10 over -2, which is -5. And we can see at some point in there, there's going to be a slope of -5. So we state, okay, since the function, since h of c is continuous and differentiable, by MVT, there must exist a c such that h prime of c equals -5 by the slopes or average velocity. All right, have a great night. I'll see you tomorrow.